Today we have a special guest, Bob Sorensen.
There is a big quantum computing conference going on this week.
So we're looking at about a 22% increase in that quantum computing market.
From Orion X in association with Inside HPC, this is the At HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Hi, everyone. I'm Doug Black, Editor-in-Chief at Inside HPC. With me is Shaheen Khan, Technology Analyst at OrionX.net, as usual. And today we have a special guest, Bob Sorensen. He is Senior Vice President of Research at HPC analyst firm Hyperion Research. Bob, welcome.
Great, Doug. Thanks. Happy to be here today.
Bob, what a pleasure to have you. To our listeners, there is a big quantum computing conference going on this weekend. I was there in person and Bob was presenting remotely. So, we got first dibs on Bob after this conference.
Yeah, so Bob, on that quantum survey that you've done, you were looking at market sizing and overall market trends. Maybe you could give us an overview of some of the key findings and maybe some of the revenue numbers as they stand now and projections for upcoming years.
Yeah, great, Doug. Let me just jump right in then. But before I get to the actual numbers, I just want to give what I like to call a little confidence building measures. The idea that the numbers you're about to hear did not come into my head random willy-nilly. I like to provide estimates and projections and such based on data-driven analysis. And so the analysis you're about to hear was really based on a study that we completed over about the last 4 months, where we touch base with exactly 112 different quantum computing suppliers from around the world. And that was, I think, one of the most interesting aspects of this particular year's projection is we really made an effort to reach out to not only the US quantum computing supply base, but also we got great participation from the EU organizations, as well as a number of organizations in the Asia Pacific region, including China. So there was a certain sense of global participation in this particular study. And we got a lot of good insights and a lot of good results and data from, as I said, 112 different quantum computing suppliers around the world. And that includes the entire food chain of the quantum computing ecosystem, all the way down from folks who are doing hardware research and quantum computing hardware product development, all the way up to organizations that are looking at theoretical algorithmic research and purely based at a software level. So we really tried to encompass exactly what's going on across the entire quantum computing spectrum. So based on those surveys and some of the analysis that came out of those surveys, Hyperion Research is basically saying that we estimate the 2021 global quantum computing market to be worth about $490 million. And what that comes with is an anticipated compound annual growth rate for the next 3 years out to 2024 of 21.9%. So we're looking at about a 22% increase in that quantum computing market over the next 3 years on an annual basis, which gives us an estimated global quantum computing market out in 2024 to be worth approximately $900 million. So the key takeaway there is that the market is stable, and this is the second version of this study that we did, and we started with data points that began in 2019, which basically said we are on track. The sector is growing, it's vibrant, and there's a predictable curve of upward trend in the revenue base. Now, what that means, interestingly enough, is we still are looking at a very wide composition of quantum computing suppliers. In fact, one of the things that surprises a lot of people when we look at the companies that we talk to is over half of them had revenues, or I should say estimated revenues in 2021 of less than $500,000. And of those 49% of the companies we talked to, half of those had no revenues in 2021. In contrast, about 7% of those 112 companies we talked to, so we're talking about 9 or 10 different companies, had revenues that were greater than $10 million last year. So there's a wide range of participation within the quantum computing sector.
I keep joking that for a market that doesn't exist, there's a market that does exist in quantum computing. And this really shows just how much progress has been made in this market, that this thing is rapidly becoming real.
You're exactly right. And I think that's a great point. And, I'm a natural skeptic at heart. And while it's great to go talk to and get really good information from the supplier base, what I wanted to do was make sure that we were capturing the most objective perspective on this. So in the companion effort to this is something I did a few months ago, which we went out and talked to about 415 current and anticipatory quantum computing end users
Hmm.
to see what their perspective was. So not only did we want to get the kind of the push of quantum computing, we wanted to get the pull. And what we found is of these 415 companies that, again, wide diversity, US, Asia Pacific, EU, we found out about 70% of the companies out there already have some form of in-house quantum computing program. Now that could range from having a small number of people monitoring the technology all the way up to things like pilot programs where money is being committed to actually explore how you can drive quantum computing into, say, either a business practice or an R&D practice within a company. And we also found that of the 30% that don't have anything now, 2/3 of those are planning to stand something up in the next few years. So this not only says that the suppliers have a degree of optimism that frankly surprised me with its enthusiasm, but also from the end user perspective. There's a lot of organizations out there right now who are saying it's time for us to start exploring what quantum can do for us from an innovative perspective, from an R&D perspective, and ultimately from a competitive advantage perspective.
What I'm also observing is that some of these emerging technologies, and quantum computing is a great example of that, even beyond AI, are looking to organizations as an imperative and that they cannot afford not to have a seat at the table.
It's an interesting point because, as I used to say a few years ago, that FOMO, the fear of missing out, was one of the reasons why so many organizations were exploring quantum. But I think what we're seeing now is glimmers of expectation. We're on the verge of real world use cases, real world demonstrated performance advantage now. So it's no longer fear of missing out as much as it is, it's time for us to move forward. We want to make sure we're properly positioned.
So we can expect some acceleration here.
As long as we have, and I hate to use this phrase, as long as we have a collection or even one killer app
Right.
in the quantum sector, the acceleration is going to happen. I like to point out to people who aren't as old as I am that, what made the PC work was every office had to have Lotus 123 and a machine to run it back in the early days of the PC. And if we can get the sector to really come out with one or more killer applications that project planners can bring to the C-suite and say, here is a certifiable performance indicator that says we'll either be able to do more work, we'll be able to innovate in some way to demonstrate value added. The acceleration, I think, is virtually unpredictable at this point in terms of how fast that could affect the market.
I was impressed by those numbers, more so that we're moving pretty quickly toward $1 billion market for a technology that is generally regarded as somewhere off in the future. So what are people using as platforms, if you will, upon which to generate these revenues that's going to the quantum vendors, either software or hardware?
Well, first off, let me answer. I never answer the questions directly. You'll find that out. The issue here is this is not a phenomenon where we have a small number of very enthusiastic, high revenue driving early adopters. We ask a lot of companies, both from the end user and the supplier base, which is the top application space or which sector do you think will be the most promising? And what we get is not, it's going to be these two sectors. What we get is it's going to be cybersecurity, it's going to be financial sector, academics, governments, computer data engineering, automotive, aerospace. It's about the broad range of applicability across a number of sectors as opposed to a degree of high enthusiasm in a small number of sectors. So I think that's the first answer to the question. What's driving the revenue is how much applicability there is across the entire traditional IT space who want to explore quantum. The bottom line is, though, right now, when we ask users and even vendors where they see the revenue coming from, it basically can be summed up in the single word cloud. It's the cloud access model where folks are looking at how do I get access to quantum computing? How can I kick the tires? How can I think about bringing quantum computing capability into my workload environment? They're not thinking on-prem. They're thinking, let's at a minimum do cloud-based trial period, low barrier to entry, low cost. It's not like when in the old days when you wanted to get a Cray to do HPC, you had to spend $25 million and hire a whole staff of technical experts to run it. Nowadays, you can explore and incrementally bring quantum computing into your workload environment in a low-cost way. And I think between the fact that there's so much opportunity and the fact that the barriers to entry to kick the tires on quantum, if you take the integral under that curve, you start to get some real numbers.
Yeah, it's such a perfect technology for cloud because it's early days. You don't quite have your killer app yet, as you mentioned, and it's expensive equipment. Not everybody has it. You're not going to have one locally. Now, there are people who buy their own, and I think there are several examples of folks who have on prem equipment, but it just seems perfectly suited for this.
You're right. There will be an on-prem market. National security agendas will drive on-prem. The needs for, say, proprietary confidential information, and you can think about, say, pharmaceuticals or the financial sector, where the imperative is to keep the data as close to home as possible. So I don't want to say that there will never be an on-prem market because, frankly, I think, say, in the next 5 years, maybe a third, maybe even more of the hardware base will be going to on-prem installations.
Right.
But what it does is it eases the barriers to entry at this early stage.
Well, the other thing is that if you are going to have a quantum coprocessor accelerator that's going to make something you're doing like a million times faster, then maybe you don't need such a big one. Maybe if the price is reduced and if the sizes shrink and eventually that's all going to happen, then maybe an on-prem quantum accelerator may just be a suitable thing to do. But we're not there yet.
Exactly. And I think what's going to happen in terms of the on-prem requirement is it's going to be not a single job, that kind of traditional HPC where you run a job for 3 months or 2 weeks or whatever, long periods of time on a single job. I think what we're going to see is lots and lots of smaller jobs that reach out and grab the quantum acceleration when necessary. It's going to be a different kind of composition. I see a large number of smaller jobs running in the quantum accelerated realm than I do what's more traditional in the HPC world, where for the most advanced data centers, you have a small number of larger jobs.
Bob, we hear that it's sort of a qubit race. How many qubits different companies doing R&D on the hardware side are doing? Is anybody out ahead in this quantum race, or is that too early?
This is a marathon. This is going to take a reasonable amount of time before a single leader or some class of leaderships emerge. We're in the first mile of the marathon, and we know who are the leaders of the pack. We know the companies that are well positioned to take leadership. We know the companies that are going to have to do some work to catch up, but it's really too early to say who's going to win the race. We can identify the leaders, but at this point, it doesn't make any sense to say these guys are in the forefront because there's so many unknowns about the technology. There's so many different moving parts. All it takes is an advancement in an existing or perhaps even a new quantum modality to change the calculus of the hardware base. As I said, the killer app, an interesting breakthrough in an algorithmic perspective, again, changes the calculus. So the point is, enjoy the ride at this point. It's filled with innovation. Don't fixate on winners or losers. Don't count qubits. Don't get involved in those near-term concerns right now, because the big picture, and it's what we talk about in HPC, mega flops, top 500 list, all that stuff is interesting. But what matters at the end of the day isn't time to solution, it's time to science. It's time to results.
The reality is that the industry has not reached its transistor moment, if you will. There's still debates on exactly what kind of technological foundation is most suitable. And I think once that happens, then you can see the industry rally behind that particular technology. And then you'll see this kind of trajectory that we've seen with traditional computing after the advent of transistors and then, printed circuits and then on and on.
I agree completely. I could even be more provocative and say maybe the quantum accelerator of the future will be application specific. So maybe there will be some applications that will live best in a photonics modality, others in a superconducting qubit modality,
Right.
and others in a trapped ion. And that may be application specific. So you have a compiler that picks the best hardware scenario. Who knows?
Who knows? In fact, as you know, there are vendors who are pursuing that kind of a hybrid model because they want to hedge their bets. And also, I think some of them scientifically see it that way.
Exactly. To me, and you talk about metrics of performance and such, what modality has the best potential for scaling? How can I get to 1,000,000 qubits? It'd be nice to have a small number of perfect qubits, but if I can get to a large number of not so perfect qubits, I can cover up for some things. So I'm looking for a technology that scales perhaps more than fixates on perfection or at least improvement at the single qubit level.
Right. So this mention of 1,000,000 qubits is really interesting because we are really talking about tens to hundreds of qubits right now. And in the transistor model, we now are 55 billion transistors on a die. So we've got ways to go in this market. But what do you see in terms of the applications that are driving this market? For example, quantum chemistry has been mentioned as a natural fit. Obviously, folks who are playing with quantum computers want to have access to some machines. So right there's an application. What else do you see in that area?
The first thing is we're not at a million error-corrected qubits yet. So we have to deal with the noisy intermediate stage quantum systems that are going to be around for the next few years at least, which means we need to find error-tolerant applications, things that are forgiving or don't demand the kind of precision that we've come to expect when we're doing 64-bit floating point.
Yeah, this is what I was calling embarrassingly quantum.
Yeah, I love that phrase, exactly. And so the bottom line here is, which are the most error-tolerant applications? And to me, the issue of optimization just pops to the fore, because you don't need the perfect solution to, say, a traveling salesman problem, because you don't have the quantum hardware to do the perfect solution yet. But in the era of NISQ machines, you have the opportunity to come up with a solution that's better than what you get in a classical counterpart in the very near future. So to me, it's how can we get better results that are error tolerant, and optimization is perhaps the one that offers the greatest opportunity to give some improvements over classical, even though it doesn't reach the full potential of a wonderfully universal error-corrected quantum computer just yet.
Within that, what sort of market segments do you see?
One of my favorite examples, I want to say it was at Q2B a few years ago, where Airbus announced a program to have people look at applications relevant to Airbus for quantum computing. And one of the ones they had was, what's the best way to load luggage onto the cargo hold of an Airbus plane that's sitting at a gate waiting to turn around? There are so many different examples of how you can optimize a process to give you, in some cases, maybe just a very small improvement, but if it scales, one of my favorite examples from the HPC world is one of the major delivery companies. It was either FedEx or one of those where they rerouted all of their delivery vehicles not to make left turns anymore, because there's something horrible about sitting at a left turn that you don't have with a right turn. And the numbers they came out with, they said, we just save $15 million a year in fuel costs because of this simple change.
Amazing.
So the plethora of interesting optimizations on any complex process, even if it's a tiny bit better than what you can get in the classical counterpart, if it scales, then you have something that could be significantly, demonstrably revenue generating.
That's awesome.
It piles up the revenues, right. Okay, well, I guess that's all we have time for. Sadly, we didn't ask Bob to explain how a qubit can be a 0 and a 1 at the same time, but maybe next time. So that's this episode of At HPC Podcast. It's great to be with you again, Shaheen and Bob. Thanks for joining us as our special guest.
Thank you, Bob. What a pleasure.
Yeah, thanks for having me today. It's great talking to you two guys. Really appreciate the time.
That's it for this episode of the At HPC podcast. Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen. The At HPC podcast is a production of OrionX in association with Inside HPC. Thank you for listening.